July 20th, 1969, humans walked on the surface of the moon for the very first time. Black and white images of the moon's surface flashed on television screens everywhere. The whole world was watching. Let's journey back to the time, the first-hand account of the historic event.
This is Jane Wilson reporting live from the Mission Control Center in Houston. As you know, 4 days ago, on July 16th, the Apollo mission lifted off from Cape Canaveral, Florida. The 3 astronauts on board had traveled 240,000 miles, or 400,000 kilometers, to the moon. In just minutes, they will attempt the first moon landing. Their spacecraft has separated into 2 parts: the command Mandel Columbia and the lunar module Eagle. Columbia is piloted by Mike Collins. It will orbit the moon, while Eagle, piloted by Neil Armstrong and Buzz Aldrin, makes the historic landing. Let's go to Pete Brooks in the studio for a historical perspective.
Thanks, Jane. I'm here with Dr. Vargas. He's an expert on the history of the United States space program. Dr. Vargas, why is this mission so important?
For years, Pete, the United States competed with Russia to have the best space program. It all started on October 4th, 1957, when the Russians launched Sputnik, the first satellite. Then on April 12th, 1961, Yuri Gagarin, a Soviet cosmonaut, became the first person in space.
Americans were taken by surprise?
Absolutely, they felt defeated.
What turned things around for the U.S.?
In 1961, President Kennedy challenged us to put a person on the moon by 1970, and today the world is witnessing our effort to fulfill that challenge.
Thank you, Dr. Vargas. Now let's go back to Mission Control and Jane Wilson. Jane, are you there?
I am Pete. The command center at Houston is a huge room filled with workstations. As many of these stations, mission control experts monitor important data coming from the Apollo 11 monitor important spacecraft. You can feel the tension in this room right now. I'm standing with some very special visitors. With me is astronaut Mike Collins' wife, Emma, and their 2 children, Todd and Amanda. They are joined by 2 mission control experts. Can you tell us what is happening now?
We're standing in our communications area. This is where we monitor the instruments on Columbia and Eagle.
Wow, I've never seen so many computers in one place.
If you think these are impressive, you should see the Columbia command model. That's where your dad is now. Behind the command model is the surface model. That's the part of the ship that holds fuel, oxygen, and navigational equipment.
We're really proud of our dad.
Would you like to speak to him now? We have Columbia on our radio. Here, say hello.
Hi, Dad.
Hi, Dad.
Hi, kids. I wish we had a telescope that could let us see that.
Todd, the most powerful telescope in the world couldn't see something as small as Columbia. It's too far away.
Your mom's right. Think of how far away your father is. This rocket goes 24,000 miles per hour, and it still took him 2 days to get to the moon.
My dad went 24,000 miles per hour.
That's right. And do you know why?
There's no air and very little gravity in space, so you can travel very fast. Newton's first law of motion states that once you are moving, you won't stop or change directions unless a force acts on you. In a car, friction with the ground constantly slows you down. In an airplane, air resistance works against forward motion, but in space, there's nothing to stop you.
But because there's air and gravity on Earth, it took tons of fuel to lift off, right?
Right. Remember the rocket that launched this mission had 3 stages. The first stage had 7.5 million pounds of thrust. That's a lot of power. The rocket pushed off the ground on a jet of superheated gas. The second stage needed less than half the power because the rocket was lighter. After all that fuel burned off, the third stage was the smallest, even though it carried the astronauts the farthest.
But if there's no air to push against in space, how does the rocket move forward?
Good question. That's Newton's second law of motion. Every action has an equal and opposite reaction. When the exhaust gases leave the rocket, they push back, and the rocket moves forward. On liftoff, the force of the exhaustion gases moving down propels the rocket in the opposite direction, up with the same force.
Dad, are you still there? What did it feel like during liftoff? We were 3 miles away and we felt the ground shake.
It squashed us in our seats until we could barely breathe. It added G's or gravitational forces. Right now, Amanda, you feel 1 G. On liftoff, we felt 3 G's. It was like being at the bottom curve of a roller coaster. Cool.
You need all that thrust at liftoff because the rocket is so heavy.
But it weighs almost nothing in space, right?
If your dad wanted to, he could push the ship with his hands.
That's pretty amazing, isn't it, Amanda? Mom, didn't you say Buzz and Neil won't weigh much on the moon? Yes, I did, Amanda.
Your mom's right. Another one of Newton's laws says that gravity attracts all masses to one another. And the greater the mass, the greater the gravity. The moon's mass is about 1/80th the mass of Earth. Its gravity is about 1/6 the gravity of Earth. On Earth, the 2 astronauts who will walk on the moon each weigh 360 pounds with their spacesuits on. On the moon, they weigh only 60. Neil, what is your status?
We're approaching the landing site. It looks pretty rocky. I'll keep moving to see if I can find a smoother spot. It's mostly gray, but when I pick it up, it looks brown or black. The horizon seems much closer here than it does on Earth. But wait, what's that I see coming up just over the hill?
What are you seeing, Eagle?
It's the Earth rising like a pure sunrise in the morning. It's the most beautiful thing I've ever seen.